Hi viewers, how are you all? Myself Nagappa, you are watching Appa Chemistry classes. Our today's topic is batteries. Okay na? So it is the second last topic in electrochemistry. So far we had discussed all the concepts which are present in electrochemistry. So I think so it is in the 13th part of the electrochemistry. Now those who not watched the previous videos, you see in the end of the screen you will find the playlist, and also you can see in iCard. So in that iCard also you will have all the videos. So now today's topic is batteries. Before this batteries, we had discussed the concept of electrochemical series. So what is the electrochemical series and what are the applications of electrochemical series, that we had seen in the previous video. That also you will see in the end of this screen. So now today's class is batteries. So these batteries are how many types? So what are those? We will take one example in each case. We have mainly two types of batteries. Those all we will see once. So till now, those who not subscribed, please do subscribe for more videos. You will get complete chapter videos. Okay, let's get into the video. So now batteries. Batteries are nothing but what are electrochemical cells which are arranged in series. Okay, so batteries are nothing but what are which are and electrochemical cells which are arranged in series connection. Then they are said to be what? Batteries. Batteries are nothing but electrochemical cells. Now in those electrochemical cells, what happens? Chemical energy is converted to electrical energy. Now there are mainly two types of batteries we have. Simple example I will tell you simply. So whatever the clock watches will be there, no? Okay, electronic whatever the watches we are seeing, wall clocks, or whatever now we got the electronic watches, but before that we have the battery containing watches. So whatever the battery which is present in watches, and also whatever the torchlight which we are using. Okay, so whatever the laser light we will use, there you will find some cells in that. So those are what comes under primary batteries. So what is mean by battery? What is mean by here primary battery? These batteries are classified into two categories. Okay, what are those? Primary battery and secondary battery. Primary battery in the sense, the battery which cannot be reused. Means, so whatever the chemical substance which is present in that battery will be converted to electrical energy, but again it cannot be reused. Means after repeated using of that battery becomes dead over. It becomes dead. So then we have to replace with that new battery. Is it or not? So whatever the torch light, if you had seen, if we are not getting proper light, means we'll change the batteries. Is it or not? Those are what comes under primary battery. Primary batteries are nothing but the batteries which are used in a repeated manner and they becomes dead over after repeating using. Is that clear? Those are said to be what? Primary batteries. Okay. Secondary batteries in the sense, whatever the battery which we are using in mobiles, mobile phones, electronic batteries. Yes, secondary batteries are nothing but what? The batteries which can be reused. Means, say for example, my phone battery is there. That phone battery, whenever I charge that, then what happens? The electrical energy is stored as what? Chemical energy in that battery. After removing that battery, after disconnecting from the external source, then what happens? Whatever the stored chemical energy will be converted to electrical energy. So if that whatever the chemical energy which is stored in the battery, if it is completed, then our battery becomes dead. It comes to the 0%. Then what we will do? Again we will recharge it and again we will use. Such type of batteries are called secondary batteries. The batteries which are reused by charging and by discharging, such type of batteries comes under secondary batteries. We will see later. So first we will see the primary batteries. What are the examples of primary batteries? Dry cell, mercury cell you can take. This dry cell is there, no? It is mainly used in torches and clocks and what are the transistors. In all those cases, these dry cells are used. Now this dry cell is also called Leck launch cell. This dry cell is also called Leck launch cell. Okay, na? Now this dry cell I will explain. Mercury cell is not that much important. Just you see here. This dry cell contains the water. One carbon rod will be there. That is what we are calling graphite rod. When you break that dry cell which is present in torchlight, you will find easily. That is what this is a graphite rod, carbon rod. which act as cathode, and which is lined with what? The zinc metal. Okay, this is a zinc cap which is lined in between the zinc rod, and which is surrounded with some chemical. The zinc rod is said to be what? Zinc cap is said to be anode, and whatever this part will be there, this part is packed with cardboard. Now here, the whatever the carbon rod will be there, no, this carbon rod is surrounded with a paste of ammonium chloride and zinc chloride. The paste, the whatever the complete this carbon rod, which is surrounded with what? Paste of ammonium chloride and zinc chloride, and which are separated by, now which is having the what? One porous part will be there, and after that we have the what? Mixture of manganese dioxide and carbon will be there here. This manganese dioxide and graphite or carbon, which is separated from this paste by this porous part. Okay, now this is a porous part. Now that is the complete actual setup in case of primary battery, that is dry cell, in the dry cell. So what happens actually, what type of reactions takes place here? What is the cathode, what is anode, that is very important, and what type of reactions that takes place at carbon, at anode and cathode we have to see. Here anode is what? Zinc rod, so carbon is what? Cathode. Okay, na? So it is what? Porous sheet which separates these two mixtures. Is that clear? That is the setup of dry cell, that is also called Leck launch cell. Now you see the reactions at cathode and anode, what happens? We know that anode always oxidation takes place. This is anode, the oxidation is taking place, that is anode is what? Zinc. Excuse me. Zinc electrode is oxidized to zinc plus 2 electrons. Now at cathode what happens? We have the cathode, this is a cathode, this cathode contains manganese dioxide, okay, which is dipolarized with this molecule, this paste, ammonium chloride and zinc chloride. So this manganese dioxide react with this ammonium ions which are present in this surrounded by this cathode. So those two react by gaining the electron, because cathode reduction reaction takes place. So we are getting the ammonia here. So this reaction can be written in another manner also, MnO2 plus water, that is the moisture which is present in it, will gain the electron and will form the water hydroxide ion. Either any one reaction you can. Now in this case, this manganese dioxide is there, no, it acts as cathodic depolarizer. Okay, na? So now in this case what happens? This reaction is there, no, this ammonium chloride. This ammonium chloride what happens? Will form the water ammonia and chloride ions. This chloride ions neutralizes the charge which is present around the cathode. Then what happens? It is the secondary reaction in a dry cell. It is a secondary reaction. Overall reaction will be what happens? Whatever the zinc ions which we got at anode, those anode zinc ions react with this ammonia molecule in presence of this chloride ion, they forms the complex. So whenever the complex is formed, whenever it is undergoes ionization, we will get the three ions. So it is having the what? Ions, so it conducts the electricity. So its potential is measured as 1.5 volts. Is that clear? That is primary battery. And one more primary battery example is what? Mercury cell, whose potential is 1.35 volts. Just to do remember as board exam point of view, just what is meant by primary battery. The batteries which are used only once. After using of those batteries, they becomes dead over. And what are the example for primary battery? Dry cell and mercury cell. That's it. Okay. So for objective point of view, you have to remember this explanation of dry cell also. So let's get into the secondary batteries. Next, secondary batteries. That is, what are secondary batteries here? Secondary batteries are nothing but the batteries which can be used repeated number of times. Such type of batteries are said to be what? Secondary batteries. What happens actually in secondary batteries in the sense? So first what we will do, we will use the external source to convert the electrical energy into chemical energy. So after charging, what happens? After complete charging, we will remove the external source and we will convert whatever the stored electrical energy in the form of chemical energy. That chemical energy is converted to electrical energy. Both reversible reactions takes place. Initially, when we are doing the charging, the electrical energy from the external source is stored as chemical energy in the battery. After removing that external source, the stored chemical energy is converted to electrical energy. Such type of batteries are said to be secondary batteries. Is that clear? Secondary batteries are reusable and reversible in nature. So what are the examples of secondary batteries? Lead storage batteries, nickel and cadmium batteries. You can take here this lead storage battery, which is very important one. Now in this lead storage battery, it is mainly used in inverters, and also it is also used in automobile vehicles, okay, in car batteries we'll see in general. So that is the use of lead storage battery, which is very important, lead storage battery. So now we are going to learn more about this lead storage battery. First, what is lead storage battery contain? So it is also called what? Acid storage battery, and acid storage battery is called what? Lead storage battery. In that, acid will be stored. Acid will act as what? Electrolyte. Now alkali storage batteries are called addition batteries, which is very important. One time it is asked in competitive also. That is, alkali storage batteries are called what? What is the name we will give for the alkali storage batteries? That is addition batteries. Next, more about lead storage battery. Now this is very important. Try to understand complete picture of lead storage batteries. Now cathode. Here what type of cathode we are taking here? So we are taking a grid of lead packed with plumbic oxide. So that will act as what? Cathode. Which one will act as cathode here? A grid of lead which is packed with plumbic oxide. That is PbO2 will act as cathode. Now what is the anode here? The sponge lead. The sponge lead will act as anode. Now what is the electrolyte we are taking? Acid. How much concentrated acid? That is very important. That is 38% aqueous solution of sulfuric acid is used as electrolyte, which is very important. So how much concentrated sulfuric acid we are taking? 38% aqueous solution of sulfuric acid we are using. Now next is what? Represented as. It is a cell representation of this acid storage battery, that is lead storage battery. So now you see here, this is lead. Lead is what? Where it is present? On your left hand side. Left hand side, which one will be there? Anode. This is a sponge lead which is placed in sulfuric acid, aqueous sulfuric acid electrolyte. So it has the water lead sulfate in the solid form, aqueous sulfate. Aqueous sulfuric acid is what? Electrolyte. This lead sulfate is also contact with the grid of plumbic oxide. That will act as what? Cathode, which is present in the right hand side. So simply it can be represented as, this is anodic port, this is cathodic port. Anode and this is cathode. Now we will see the cell reactions at electrodes. What happens? Yeah, reactions at cathode and anode. What type of reactions takes place we will see. When battery is in use, that is during discharging process. Say for example, we are using the after charging. What happens? The electrical energy, that is from an external source, electrical energy is stored in the form of chemical energy. Okay, na? So during the discharging process, that charge will be discharging, charge is decreasing. During the discharging process, what happens? Whatever the stored chemical energy is converted to electrical energy. At that condition, what type of reactions takes place at cathode and anode we will see. Now cathode, what is cathode? We had taken sponge lead, that is grid of lead. Lead plumbic oxide is taken as what? Cathode. Sponge lead is taken as anode. Now that grid of lead oxide will undergo hydrolysis, we will get the Pb plus 4 OH minus ions. These all reactions takes place at cathode. And also whatever the Pb plus 4 ions we got, that plumbic ions will react with the 2 mole of electron, that is gain of electron is called what? Reduction, which takes place at cathode. And whatever the Pb plus 2 ions we got, that plumbous ion will react with the sulfate ion which is present in aqueous sulfuric acid, will convert it to lead sulfate. And we have the water molecule also. Aqueous means water. 4 OH minus ion plus 4 H plus ions, we will get the 4 water molecule. Now you see here 2 water molecule, here 4 will cancel out. So how many are left over? 2. Now you see here 4 OH minus ion, 4 OH minus ion get cancelled. Now what is Pb plus 2? Pb plus 2 get cancelled. Pb plus 4, Pb plus 4 get cancelled. Okay, now what is left over? Plumbic oxide on the left hand side, sulfate ion on the left hand side, and 4 moles of H plus ion and 2 moles of electrons. Now we are getting the water here lead sulfate plus 2 moles of water we are getting. This is the net reaction at cathode, which is very, very important. So during discharging process, the reaction at cathode will be this one. So in this during discharging process, what happens? Whatever the sulfuric acid, SO4 minus 2 and H plus ions are nothing but sulfuric acid, which is converting into lead sulfate. Means the concentration of sulfuric acid is decreasing, that is converting into water lead sulfate. What is the concentration we are taking? 38% of aqueous sulfuric acid. Okay na? So in some cases they will say approximately 40%. Okay. So at anode what happens? At anode what happens? Which type of reaction? Oxidation reaction takes place. So whatever the sponge lead is there, no, that sponge lead will be oxidized to lead plus 2, that is plumbous ion, plus 2 electron. That plumbous ion what happens? How it is combined with sulfate ion? Here also it combines with the sulfate ion and forms the lead sulfate. So by net reaction, if you had written this Pb plus 2 get cancelled. So what is there? Lead, when react with sulfate ion, we are getting lead sulfate plus 2 electrons. Now we will add this cathode reaction and anode reaction. These two reaction we will add. So then we will get the water, plumbic oxide, sulfate ions. Okay na? So here 1 sulfate ion, 2 sulfate ion. So 2 sulfate ions plus 4 H plus ion. We will get the 2 moles of H2SO4. Now in this case, PbO2, plumbic oxide and lead, so gives rise to PbSO4 plus 2 H2O, because this 2 electron get cancelled. Is that clear? So during discharging process, what happens? The sulfuric acid concentration is decreasing. This is one time asked in NEET question. During discharging of lead storage battery, what happens? Concentration of sulfuric acid remains the same, decreases as a discharge process proceeds. So it increases the concentration of sulfuric acid. So none of these. So that is what they asked in the NEET also. That is very important. During discharging process, what happens? The sulfuric acid concentration will be decreases. Okay na? So it is a reversible reaction, I said, no. So that is what during discharging process, whatever the stored chemical energy in the form of sulfuric acid, that sulfuric acid will be discharged in the form of lead sulfate. If it is forming lead sulfate, means it is undergoing discharging process. Now this discharging process, what happens? Concentration of sulfuric acid decreases. When you are doing the charging process, what happens? This water react with lead sulfate. Again we will get the water sulfuric acid. That sulfuric acid is regenerated when we are doing when it is connected to the external source. Then what happens? Recharge takes place. That is concentration of sulfuric acid increases. Is that clear, everyone? Now here in lead storage battery, both reversible reaction, charging and discharging takes place. That charging and discharging takes place in lead storage batteries. So for that reason it is called double sulfatation reaction. It is also said to be double sulfatation reaction. And also the cell which is mainly tested with by determining the specific gravity of sulfuric acid. Based on the specific gravity of sulfuric acid, in an lead storage battery, it is tested whether it is in good condition or bad condition. Is that clear? So that is what lead storage battery. Now we had seen the when the reaction, when the battery is in during discharging process, we had seen. When it is charging, what type of reaction takes place? When it is charging. When the cell is in charging, then what happens? The reaction which is taking place at cathode, that takes place at anode. The reaction which is taking place at anode, that takes place at cathode. Okay na? So it will be completely reverse it is. Now what is the reaction at cathode? That becomes what? Anode reaction. So at cathode, what is the net reaction? This one. So it is reversed. That is what PbSO4 plus 2 H2O gives rise to. What happens? We will get the PbO2, plumbic oxide, plus sulfate ion, plus 4 moles of H plus 2 electron. That is oxidation takes place at anode. Is that clear? Cathode reaction will be at anode during charging process. At cathode what happens? That is anode reaction will take place at cathode during charging process. That is cathode reaction. Here anode reaction is what? This one. So it is reverse. That is lead sulfate gains the 2 electron, that is reduction. So we'll convert it to what? Pb, lead plus sulfate ion, SO4 minus 2. Is that clear? Now overall reaction will be what happens? We have to reverse this one. Overall reaction will be 2 moles of lead sulfate plus 2 H2O. Now you see here what happens? 2 moles of lead sulfate plus 2 H2O. This 2 electron get cancelled. So we are getting PbO2 plus Pb. So sulfate ions, 2 sulfate ion and 4 H plus ions. We'll get the water 2 moles of sulfuric acid. 2 moles of sulfuric acid. Is that clear? So this is the net reaction during charging process. Very, very important, these reactions at during charging and discharging. What are the reactions at cathode and anode? Most important this one. So that's it for today's batteries. Batteries are how many types? 2 types, primary and secondary battery. For each one, we had seen the example with the detailed study of reactions at cathode and anode. So if you really like the video, so please do subscribe and like the video, and don't forget to watch complete videos of our chemistry classes. Thank you. Have a nice day.